Oblique triangle trigonometry is the study of non-right triangles. We're going to start off with the law of sines, which is one of two laws that we'll use to find missing information in non-right triangles. We need to discuss what the law of sines is, when to use it, and how it's used in 3 examples, one of which will be a word problem. The law of sines is a relationship between the sine of an angle and the side across from it. Remembering that angles get capital letters and are crossed from the sides with the corresponding letter. All 3 of those could be flipped upside down, and this would be true as well. Let's look at how this gets used. This gets used in 3 situations. When we have angle, angle, side, when we have angle, side, angle, and we have side, side, angle. The third one is a special case, which we'll discuss more in depth later. Our first example is where we're given 2 angles and the non-included side. A good idea that I'm going to just suggest is that if I know 2 angles in a triangle, I might as well just go ahead and solve for the last one. Never know when it'll be helpful, you might as well have the information in front of you. So x is across from 60, which means that I can put it into a proportion with 60. Actually, what I want to do first, let's actually label our sides. Let's make this A, this is B, and this is C. A, B, C. Law of sines tells us that the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. Well, I know angle A. Side A is what I'm looking for. I know angle B, but I'm not actually looking for side B, so I'm going to skip this part. I don't need all 3, I only need 2. I need one where I have an unknown, and one where I know both pieces of information. From here, I can cross multiply and divide, and solve for x. So far I haven't plugged anything into my calculator yet. I'm going to do that last. Right now all I've done is cross multiplied. And since I want x by itself, I'm going to divide both sides by the sine of 40. This does not cancel anything. It cancels over here, but I still have to take 5 times the sine of 60 divided by the sine of 40. When we multiply that all out in the calculator, we get x is equal to 6.7. Here's one where we know 2 angles and the side between them. Again, my first recommendation is that if we know these 2, we subtract that from 180 and get this angle. Ugh, that's 60. And in this case, I do need that. So if I label my 3 sides, A, B, C, and I could label them in any order, we see that the sine of A over A, that has my unknown, is going to be equal to the sine of B over B, which I know both pieces of information. Since I don't know C over here, I don't want that one. I'm just going to use A and B. So that's the sine of 70 over x, which will be equal to the sine of 60, which we solved for, over 6. Once I cross multiply, I'm going to get 6 times the sine of 70 is equal to x times the sine of 60. Divide both sides by the sine of 60. And I'll be able to plug that into my calculator. And I get x is equal to 6.5. Last one is a word problem, so let's make sure we read carefully. We start off with the sun and a pole leading towards the sun. Here's my sun. Here's the pole leading towards the sun. Here's the grass underneath. And we have a shadow being cast by the pole, which is 22. I haven't addressed this part yet. So if we imagine a vertical line here, where the pole would have started before it started leading, this is 8 degrees right here. And then we're told that the angle of elevation of the sun from the tip of the shadow is 43 degrees. So this right here started off as 90, and then we leaned 8 degrees away from it. So we're going to get, right here, 98 degrees. I have angle, side angle, so I can use the law of sines. I'm solving for this side right here, which is across from 43. So let's start with that. Sine of 43 over x. We don't know this angle up here, so we should probably solve for that. That's 39 degrees. So the sine of 39 over 22. I skipped over a little bit of the work, but you can see that I cross-multiplied and then divided by sine of 39, and we end up with 23.8 feet. That's it for today.